In this video, we investigate the correlation between a response variable R and two input variables V1 and V2. We start by looking at the simple bivariate correlation coefficients between each pair of these three variables. We go to Analyze, Correlate, and we start with bivariate, and we select the three variables R, V1 and V2, and we are looking for the Pearson correlation coefficients, so we click OK. This table between the three variables gives the individual bivariate correlation between each pair of variables. And so between V2 and R, we can see a correlation coefficient of 0.784, which is highly significant with a p-value of 0.007. And between V2 and V1, a significant correlation again with a p-value of 0.004. As V2 shows significant correlations with both R and V1, it is not surprising that there is also a correlation between V1 and R with a coefficient of 0.678, which is significant with a p-value of 0.031. The apparent correlation between R and V1 can be difficult to interpret because both R and V1 are themselves correlated to the other variable V2. We will now look at the effect of partial correlation between R and V1, which is the correlation after the effect of V2 has been removed. So we go to Analyze, Correlate, and now Partial Correlation. So now we're looking for the correlation between the two variables R and V1, but we want to do this after we've taken the effect of V2 out of the equation. So we want the partial correlation of R and V1 while controlling for V2. And we click OK. So now for the correlation between R and V1 controlling for V2, we find a partial correlation of 0.102, and we find that the p-value has changed from the bivariate value of 0.031 to the partial correlation value of 0.794, which suggests that much of the variation in R can be predicted by just referring to the variable V2. However, we can also measure the partial correlation going the other way. So we can go to Analyze, Correlate, Partial, and now we will get the correlation between R and V2, but we will control for V1. We see now that the bivariate correlation of R and V2 with a p-value of 0.007 has become a partial correlation of 0.131, which is consistent with the fact that the variable V1 could also be used to predict much of the variability in R. These results do not specifically decide whether there is a scientific cause and effect link between R and V1 or between R and V2, although the relative magnitudes of the correlation coefficients do indicate the strongest direct relationships.